Thank you. Good afternoon to everybody. Okay. We are speaking very briefly about which is the strategy to reduce the CO2 emission on a broadband network, starting from equipment, which is other type of a reduction of emission on a broadband, giving an overview of the possibility. And after looking on some green case of Huawei that is doing in the telecommunication field. Okay, starting from which is the actual situation of broadband access that is very growing in the last year. This data are taken from a report of CONCOM to European Commission. We can see that the increasing of the broadband line is continuing. This is have a big impact on power consumption for ADSL service, because we can estimate to have in 2011 1,000 of megawatt per hour of consuming for the ADSL line if we make any intervention on this. The first intervention that was made in collaboration from GRC, the operator, and manufacturer side, is to write a code of conduct. And the code of conduct have in two steps of impact, have impact to reduce on 2011, estimating obviously the number of equipment of about 60 tons of CO2 for any hour. This is equivalent in of 5 to 5,600 tons of CO2 in 1 year or less. And this is a first step from the manufacturer of telecommunication equipment has been done to reduce the impact of broadband. But it's not the only point in which we can be active. We have a more effort if you speak about new network architecture for the telecommunication line. We can improve the efficiencies of equipment, looking on DSL, chipset, and also on some other circuit. And another point in which can be active is the infrastructure updating. Thinking in new type of infrastructure, new type of solution for cooling, and new flexible energy sources, as said before, thinking about wind and solar and biofuel maybe, is a new opportunity to reduce the impact of the CO2 for broadband technology. Okay. Speaking about architecture, network architecture, this is a slide from a presentation from British Telecom, in which it said that moving the integrated hatches and the backhaul, speaking with photonic core in a long-term vision, we can move all to the customer, and there is in the network a reduction on about 100 of exchange room. An exchange room, less exchange room, we said less necessary to have cooling on the room, and is a big impact on the emission of CO2. Another point is speak about the traffic management DSL. In ITT is working, and there was defined also in the code of conduct, have a target for the different type of traffic management, L2 or L2 or L3. Is said in the sense, in practical sense, that when there is no need to transmit data, please switch off the power on the line. On this data, you can arrive on the 2011 using the code of conduct value of 2009, have more 25 tons of energy of CO2 emitted on emission that can be solved respect to what we make using exclusively the L0 mode, said anytime you transmit all the power. These values are taking into account considering some average user of equipment, taken from some ETSI report. Now we are speaking is about the equipment efficiency, looking which is the component that is present in the market, because from a manufacturer point of view, we can have a goal to reach reducing the power also if component manufacturer help us. And what we have said that looking possible chipset vendor is the component that is the core of the broadband equipment, are following this trend in the sense that are estimating to have passing from 1,600 milliwatt to 1,000 milliwatt. So in this way, we can be able to have a more efficient equipment in the future. Another possibility is to work in a more efficiency power model. But in this case, we have to look at which is the best result, that is the green line, have a more efficiency on the equipment, with which is the cost to do. And anytime we have to balance which is the cost for efficiency and which is the cost for the equipment. In this way, we have a more stable DC-DC efficiency. That is very important also when we implement the traffic management, because in the other case, we are losing completely the advantage of the traffic management. What is making Huawei is the first, okay, we meet the requirement of a code of conduct on our equipment. But we are making a union platform. We say that the same platform for all type of solution for the access. This is protected the investment from the operator, but it is also easy to planning, easy maintenance. You have only one unit for all type of equipment. That is a lost cost of logistics. Lost cost of logistics said also lost transportation, and is also energy saving on this point of view. We have a wide operating range of equipment, said that no need to have high cooling efficiencies, no high cooling working time. And then we pass at a dynamic power control of the equipment, and we send to control the fan speed depending on the temperature, to switch off boards that are not utilized in this moment. And the sales implemented the traffic management. And also our way is estimating which is the network carbon footprint of our access line division. And this will be estimated at the end of this year, next of 2009. Another solution that we have implemented also in the British Telecom is the 20C MSN, that is based on EP switch exchange serving. It's about 5,000 of customers. We are passing from the actual situation. We have a lot of equipment, and an estimated power consumption is about 800 kilowatt. To the new solution MSN, we have a very small equipment, less equipment, and a power consumption of about 1,100 kilowatt. This is estimated from BT. In the future, we can arrive at the power consumption of 100 watt. All these equipment are compliant with the code of conduct at 2007, 2009, and will be compliant in 2009 with the code of conduct. These solutions have a CO2 reduction from 4,000 tons per year to about 500, and it's very much. This is considered only one center, only one plant, and not all England. Okay. Now the solution is speaking about free cooling. This is a solution that was used a lot in China, and is The same solution applied on the big station is possible to apply also on the cabinet. That is the future of the development of broadband telecommunication in the world. On this solution, we have a reduction of 50% of the power consumption for the cooling. That is, if you consider it's not a big amount for any cabinet, but you have to consider that this cabinet is very spread on the country. And the failure rate is similar to the normal application. Another solution very innovative is passed to a cool innovation using the ground, the soil. This is respect to the previous solution, have a very big advantage to require less maintenance because there is no air filter, there is no need to send men to look on the equipment. Then the last is Huawei is working also in the cooling of central office. We have experience in China in which we can optimize the cooling of a data center, of a central office, and we can arrive at an average power reduction of 50%. And you have to consider that the cooling is the major power consumption in telecommunication field is due to the cooling, actually. Okay. Okay, just to finalize, Huawei is making an LSI analysis to minimize its footprint. All our equipment is in line with the code of conduct. We are working on cooling high efficiency solution. We make energy saving analysis on the board of our equipment. And we are active on supporting green standardization in ETSI level to make a lot of document on the measurement method and on energy saving equipment. Okay, thank you very much for your attention.